In our next example, we're given three functions to work with at one time. So I'm going to let f of x be orange. We have g of x be purple. And then I will let h of x be blue. All right. Notice that they are all polynomials, which means that we have no restrictions starting out. We may pick up restrictions on the way, but we don't have them right now. We're asked to find g of x plus h of x. I'm going to put parentheses. We have 3x minus 2 plus h of x, which was my 9x squared plus 18x minus 8. Because we do not have a negative to distribute or coefficient to distribute or anything to multiply, we can drop the parentheses. So this becomes 3x minus 2. When I have plus a negative, it just becomes minus 9x squared plus 18x minus our 8. We're going to combine like terms and write our answer in descending order. My 9x squared comes first, so negative 9x squared. Then I have an 18x and a 3x, which gets me plus 21x. And then I have a negative 2 and negative 8, which gets me to negative 10. We're not asked to solve anything. We're not asked to plug anything in. So we are done. We just found g of x plus h of x. They didn't ask us to find the domain, but we could if we really wanted to, because we had no restrictions starting out. And then our answer is a polynomial. We didn't have any denominators in between, which means our domain would be negative infinity and positive infinity, all real numbers. In our next one, we have h of x, which is my blue function. And I need to subtract my g of x, which is my purple function. This time, I can't just drop the parentheses because I'm going to need to distribute that negative through g of x to each term in g of x. For h of x, there's nothing out front, so I can drop the parentheses and just write down my negative 9x squared plus 18x minus 8. But I need to remember 3x plus 2 because I have a minus and negative. And then I'm going to write my answer in descending order again. So my negative 9x squared comes out. I have 18x minus 3x, which gets me a positive 15x. Then I have negative 8 plus 2 to get negative 6. And we just found h of x minus g of x. Again, we didn't have any radicals. We didn't have any denominators that we had to worry about. So if I were asked to find the domain of this guy, it would again be negative infinity, positive infinity, because no restrictions going in, no restrictions coming out. In part C, we're asked to find f of x times h of x. And f of x is my orange function. We haven't used him yet. He's 5x. So I'm going to have 5x times, I'm going to put parentheses instead of the dot. So parentheses, my h function, which was my blue function. And now that I'm here, I need to distribute my 5x through all three terms of my h of x. 5 times -9 gets me -45. Next times x squared gets me x cubed. Plus, because I have a positive 5x and a positive 18, let's see, 18 times 5 gets us 90, and we have x squared from x times x. And then 5 times 8 gets us -40 with our x. Again, we can't combine any like terms because everybody has different exponents, so there are no like terms. They're not asking us to solve anything, just to do the multiplication, which means that we have our answer, the -45 x cubed sorry about that, minus the 40x, or -45x cubed plus 90x squared minus 40x. Okay. Our next one says h of x divided by g of x. So I need my blue function, the -9x squared plus 18x minus 8. I'm going to divide that by my purple function, 3x minus 2. Here, we know that we have a restriction. It's not asking us to find the domain, but if we needed to, we would take the 3x minus 2, set it equal to 0, and find out that x equal to 2/3 is our restricted value. But we were asked to find everything in simplest terms. So we need to look at if we can factor -9x squared plus 18x minus 8. Remember, we don't like to start on a negative foot, which means that we need to get rid of that negative. Now, do they have anything in common other than the negative? No, because 9 is only divisible by 1 3 in itself, and 3 doesn't go into 8, neither does 9. So 9 doesn't go into 8, 8 doesn't go into 9. So our only GCF is -1. Factor out our -1, we're left with 9x squared minus 18x plus 8. We're looking for a product of 9 times 8, which is 72. And then we're looking for a sum of our middle term, which is -18. Remember, you can always work your way through this by doing like 1 and 72, but that gets you 73 when you add them. And you could keep working your way up. So you could do 2 and 36. That gets you 38 when you add them for the sum. Keep going. You're going to wind up getting 6 and 12, which gets us 18. Not quite what we need. Right number, wrong sign means go back, change your signs. We have our magic numbers now. It's -6 and -12. Which means we'd have x minus 6, x minus 12. I'm going to change the way that I circled those because it almost looks like -72. So let me fix that real quick. Okay. We're not done because we had a leading coefficient that wasn't 1. So we're going to divide by 9. Reduce your fractions. So put this in your calculator, 6/9, convert it back to a fraction, should get 2/3, and 12/9 should get you 4/3. Move your 3's up for bottoms up. We get 3x minus 2 times 3x minus 4. But don't forget your GCF, who is along for the ride. Now don't circle this answer. This is not our answer. All of this was to try to simplify in part D. We just found that the top, the negative 9x squared plus 18x minus 8, is really, in factored form, negative 1 times 3x minus 2 times 3x minus 4. And we have that all over the f of x of 3, g of x of 3 of x minus 2. Showing up in top and bottom, we see the 3x minus 2, so we can get rid of those. We wind up with negative 1 times 3x minus 4. You can stop here, or if you want to redistribute the negative 1, you could have negative 3x plus 4. Either is acceptable answer because they wanted it in simplest form, and the factored form shows that you were double checking your simplification. They did not ask us to find the domain, so we don't need to. But note that even though we wind up with a polynomial, we did have a restricted value that showed up as soon as we had the denominator. So the restricted value lives or hides here in the denominator. Part E, we want the restricted values and domains for g of x over f of x. G of x was my purple function, 3x minus 2. And f of x was my orange function that we didn't use very much, which was 5x. I did this so you could get used to seeing g of x over f of x, but really the only thing we need to know is what's in the bottom. So the top can be blah, 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 blah. It doesn't matter because our restricted values come from the denominator. So to find our restricted values, we're going to take our denominator, which is our f of x, set it equal to 0, so 5x equal to 0. When you solve, you're not subtracting 5, you're not adding 5, you're dividing by 5. And we find out that our restricted value, is x cannot be 0. There is our restricted value. We need to find the domain still, which means that we are going to be going to our friend, the number line. So the domain in interval notation, you don't have to do the number line, but if you're not quite sure, you just want that visual reinforcement, go ahead and do it. Our first part is negative infinity to 0. Parenthesis around both of them. And we're going to union that with 0 to infinity. First part, and then our second part. And we are all set. We found the domain and the restricted values.